Cool.
Yeah.
Okay, that'll work. That's something at least. All right, you guys understand that? Because on the quiz or something, I think it's sort of like, well, shoot, I didn't put it up. It's good to have unbreakable glass on your. All right, so you're just out of the picture entirely. Oh, it'd be good to have it. I was like, what's happening? Why does that not look right? All right. Oh, this is so exciting. There we go, Jeff. Hey, look at that, Jeff. Now you're showing evolution stuff happening. Okay. All right, we'll let that stay there. Any other questions from homework stuff? Okay. Let's do this then. Let's get back to this. What is that? Okay. So remind me, so we did talk about these then, right? I know I keep asking. I just can't remember doing that. See again? Okay. Alright, so I guess that we did. So number 2, this is when I was walking around the room and trying to remind everybody that this is not a piece of data. Right? So, how many people slept 5 hours? How many people sleep 5 hours a night? Yes, one person sleeps. And then 6 hours, 7. So why is this a good idea what I'm doing? We've done a couple of these tables by now.
Because you want the total.
Yeah.
You're going to add each row.
So the probabilities are always based on the numbers of things. So I want to know the total amounts of each, so that I can make all these different probabilities. So I'm always going to give you this outside little empty space to remind you. And then how many people work less than 14 hours?
8.
8, and then greater?
10.
10. So 18. Don't put 36 there. Why do you think somebody would put 36 here?
They're gonna
You see 18 people there and 18 people there, but those are of course the same 18 people. So don't give them all 2 votes, right? Okay, so what is, if I pick one student at random from this group of students, from you guys, let's probably get a student that sleeps 7 hours a night.
618.
Yeah, there's 6 that sleep 7 hours a night out of 18. And of course that reduces to 1/3, which would be 33.33%. Roughly. Alright, cool. How are we doing so far? And again, to remind you guys, the most common mistake I see here is somebody would put 1 out of 6. Can you figure out why somebody would do that? That's the part of the teaching job people don't think about. I've got to try to figure out how heinous is your mistake, and I first have to figure out what the hell were you thinking? What was the mistake about? What would that person, why would somebody put 1 out of 6?
6 times 3.
No, I mean, right from the beginning, they put 1 out of 6.
Because on the bottom of that column is a 6. And then one person out of the 6.
So they want to pick one person.
Right.
They see 6 people that sleep 7 hours, and I want one of them. But that is just nowhere near the right way to think about this. It's all about the chances. What are the chances you get somebody who sleeps 7 hours? 6 chances out of 18 total people that you could pick. I like it, maybe. So the bottom is always going to be, for this problem, the bottom will always be 18. Unless I give you information, right? It could be any of the 18 people unless I tell you something. If I told you this person slept, I know the person slept 6 hours. Given they sleep 6 hours, then what's the bottom going to be? 7. Because I'm only talking about the 7 people. I love it. So what's this one? Works less than 14 hours.
8.
Yeah, 8 out of
18.
18, which is 4 nights, which is 0.444. So it's 44.44%.
Yes.
How are we doing so far? Divided by 9 is neat. 1 divided by 9 is 0.1 forever. 2 divided by 9 is 0.2 forever.
Oh,
3 divided by 9 is 0.3 forever, which makes sense because 3 over 9 reduces to 1/3. Neato. Sorry.
Numbers, free.
Now here's the one that's freaking my stats students out right now. You guys can show them up a little bit. Sleeps 7 hours and works greater than 14. So the people that I want to count have to do both. And in probability is restrictive. It's always less than either of the things would have been on their own. You got to be this and this. So sleeps 7 hours and works more than 14. How many people do that?
4.
Only 4 people do both. And I can't remember if I said this before, but and is very often considered intersection. So what's the intersection of works greater than 14 hours? We do it over here. And very often is considered the intersection. Greater than 14 hours and sleeps 7 hours. That's the intersection right there. Is that cool? So it's always going to be a smaller, not always, but it's going to be more than likely a smaller number because there's going to be less people that do both things. I like it. So then it would be 4 out of what? Still 18 because I didn't give you any information. I haven't given you information, which is 2/9, which we now know is 0.2222 forever. Let me just slow down for a second. Yep, 2/9, which is 22.22% roughly. Wow. This is good. Either one. I talked to you guys about the nice bouncer and the mean bouncer. No?
Yes.
yes.
Some of you guys remember?
You can be red,
You guys
or
are
you can be cute, but you're
Well, you
not-
got some tips about bouncers? So, and is like the mean bouncer. You gotta know Jim, the bartender. Hey, I know Jim. And you gotta be rich. Alright, bye. Somewhere else. And you gotta drive a nice car. Well, I'm still leaving, man. Shut up. Or is the nice bouncer. So, and is always gonna have less and less and less people that match. Or is the nice bouncer. You gotta be rich. Shit. Or you gotta drive a nice car. Shit. Or you gotta know Jim. I know Jim. Hey, Jim. How you doing? Go ahead. Right? Or more people could match it because you're giving them more options to match. So works less than 14 or sleeps 6 hours. So how can you do this? Works less than 14 hours is how many people?
Works less than 8.
Yeah, less than 14 is 8.
8, yeah.
Sleep 6 hours is 7 people.
7.
But if I add those together, what mistake have I made?
You've covered somebody twice.
Yeah, these people I've counted twice here, right? Oops, sorry. These people. So I got my work less than 14, or my sleep 6 hours, so I've counted these people twice. So I've got to subtract 3. Or you could just from the beginning say 8 people work less than 14 hours. How many people sleep 6 hours that I have not counted yet? 4. So that's 12. And of course that's what I'm going to get here is 12 out of 18, which is
2/3.
2/3 or 6/9, which is 0.6666 forever. And then you can round it to 66.67%. All right, let me stop there for a second. What's up? All right, everybody just calm down. Okay. I love you guys. All right. Now here's the first ones that are a little bit freaky. These are the only times that the bottom will start off not being 18. Now earlier the bottom was not 18 after I reduced it, but that's not what my point. So here, works more than 14 hours, given that they sleep 6 hours. So people always make a mistake about which one is it that I know. The whole question is find the probability that that student works greater than 40. I don't know if they do. What's the probability they do that? Given that they sleep 6 hours. So how many people am I talking about total?
6. The people who sleep 6.
Yeah.
I know that they sleep 6 hours, so I know it's coming from this group here.
Yeah.
So out of those 7 people, how many match what I'm looking for?
4.
Yeah, more than 14 hours? 4 out of 7. Which is like 57%.
Yeah.
57?
Yeah.
0.5714.
So like 57 point blah 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 percent. Okay. Cool. Alright. Real quick. Just suffer with me just for a second. I'm a little excited about this because I never really stopped to think about dividing. But divided by 9 is interesting because it's got that repetition thing going. Divided by 7 seems like it would suck, but the funny thing, 7 times 14 is 98. Ooh. So divided by 7, 1 7th will be 14%. 2 7ths is plus 14, 28%, roughly. So it's like 14, 14 goes up by 14. So that's why 4 7ths, 4 times 14 is 56. I rounded up a little bit. Anyway, you're all like, whatever, Jeff. I'm just trying to, the more things like that you hear, the more you're more comfortable you feel playing with numbers. And it's important to be able to play with numbers in the world, believe it or not. You don't have to be able to, but you also don't have to live in a house. You can live in a cave. So here, what is it that I know about the person in part F? What is it that I know about them?
They work.
Greater than 14 hours.
They work more than 14 hours. So how many people could it be that I pick? 10.
Right.
I've got 10 people. So my whole world now is the second row. Out of those 10 people, because I know I'm only talking about 10 possibilities, because they're the people that work more than 14 hours. That's what I know. How many sleep 7 hours?
4.
4. So 4 out of 10, 40%.
40%.
I like it. Wow. Gotta love the out of 10. Alright, let me let that sink in. Oh, Charles, you didn't get one of these, I don't think. Yes.
So anytime we get the given seat, we cannot count people twice.
How do you mean? The given? No, the or.
Because sometimes we just total like we count people twice, and like we gotta.
So that's the or where you gotta be careful. This one you want to take everybody from each group, but there are some people that might be in both groups. You don't want to count them twice.
Only visible.
It'd be like on election day if I said, okay, all the women go vote. Yay. Now all the Democrats go vote. So all the women Democrats vote twice. It's like, holy shit, Donald Trump was right. Oh my God. Sorry. I should stay away from that. Sorry. Yes. Do you need a copy? Okay. Now let me remind you guys about this last question, how it works. There are 2 questions related to the probability of sleeping 7 hours up here. I know it doesn't look. There's this one, obviously. That's the probability that a student sleeps 7 hours. And then there's this one. That's also the probability that the student sleeps 7 hours. The difference here is I gave you information. I gave you more. Oh yeah, by the way, we know that they work more than 14 hours. So this last question says, are sleeping 7 hours and working more than 14 hours independent? So if I know that they work more than 14 hours, does the probability that they sleep 7 hours change? Yeah. It was 33%, roughly. If I tell you they work more than 14 hours, it becomes 40%. So let it make sense. Let this make sense. Please let it make sense. If the given changes this guy's probability, then they are dependent. What's the probability they sleep 7 hours? Well, it depends on if they work more than 14 hours or not, right? Because if they do it, it goes up. Yes, sir?
Well, are you saying this to tell us that on the test you're going to ask that question?
Holy shit. That's how college works. So I never answered the question directly about what's going to be on the test, but obviously the idea of how to tell if things are independent, that is definitely going to be on the quiz and the test. You know it. Yes, sir?
So how do you know you gotta compare to that one, to the F, not the number 6?
So here's the thing. Independence. That's what that says, by the way. It says independence. Not Independence Day, no. Especially not the second one. How do you tell if two things are independent? If, oh, did you like the movie? I'm sorry. If the probability of A given B, if B happens, if I know that B happened, whatever B is, that's the person works more than 14 hours, you have a certain type of gene in your makeup, you have whatever, right? I love that look. Not your makeup, a gene in your makeup, right? So if B happens, and A doesn't give a shit. So if B happens and the probability of A is the same, then they are independent. Let that make sense. B happens, did A give a shit? No, it stayed the same as it was before. That would mean that they're independent. One does not affect the other one. If they're not equal to, like it was on the front, they weren't equal. One was 33.33% and the other one was 40%. So the probability went up. It changed. That's dependent. Depending on if they work more than 14 hours. The probability they sleep 7 hours will change.
It's just the fact that they don't equal to each other.
They don't equal to each other. These don't equal to each other. Therefore, they are dependent. Because it doesn't match what it needs to do for independence. Yes?
So can we like write this like since A, or no, never mind.
You ready?
I would say it's right, yeah.
So, I don't have A and B here, do I? The probability sleep 7 hours given work more than 14. Does that equal the probability sleep 7 hours?
Yeah.
Do they equal? What is this one? That's part F. That's 40%. What's the probability of sleep 7 hours period? 33.33%. Not equal to dependent. Notice how I didn't write a paragraph about a person could sleep 7 hours and work more than... No, you can't explain the answer to an independence question with a bunch of words. You explain it with a bunch of math, right? And not just because I'm a math guy, but because it's a mathematical definition, that's why. Alright. And again, I did talk to you about, the reason I brought up the genes thing earlier, is didn't we talk about like if you have a certain type of gene and they realize that that means you have a higher chance of getting cancer later? Have we talked about that? That's an example of conditional probability, dependent events. You have this gene, your chances for cancer are higher, here's what you can do to lower that, right? So there are things you could do that would affect that probability, make it go the other way. Does that, right? Okay. Like basically, don't do all the things you like, basically, and then live a longer and more boring life. But I mean, that's what you get to choose.
Longer and boring.
Longer and boring. All right. Did everybody get a chance to try number 3 out? I know a few people just came in, but even those who were here last time,
I didn't get them.
be honest with me. I'll give you a couple minutes to even compare what your answer is, or to actually work on it if you haven't worked on it yet. We saw a problem like this on the other sheet. It was a little different than this, though.
This is where I need the
I'll give you a little hint.
You have to plug into the thing.
Write the formula for this, and then look at it compared to what I told you.
I did it.
We'll see if it's right.
Yeah, keep gnashing. We'll see if it worked out. No, you drew something on the board that
Okay.
looked similar. We did not discuss it.
Here, guys, to help you out with this problem, here's that other worksheet we did. Remember this one about Reddit and what the hell is it? All that kind of stuff. Everybody look up Reddit since it's actually a decent website. like any website, it's got shit parts and good parts. So, real quick, this is the other worksheet, okay? So don't look at this and go, oh, I got something else. Of course you do. This is the other worksheet that we worked on before. I don't remember this, but my hint for this one was write the formula for this. So here's the formula, right? And this is exactly the kind of problem where I warned you, you have to use the formulas. I said earlier, the earlier problems, don't even use the formulas. You can just count what you need. So probability is easier when you can just count stuff. Can you always just count stuff? Well, no. I mean, I just know the probabilities here. I need formulas then to know how they interact. So there's the formula for a piece that I tell you. So I know this. What else do I know in this formula that I gave you? What else did I give you?
A and B.
Yeah, I know the probability of A, I told you the probability of B. And what is it that I'm asking in part A? The one thing that's left, right? So if I plug in what I know, this feels familiar. Maybe I just remember talking to some individual people. 0.71 equals 0.45 plus 0.64 minus this thing, and then it's just algebra. And I know I say just algebra, right? But part of this class is assuming you know up through solving basic equations. So how the hell do I do this? Let's see, I get 0.71 equals 1.09. Right? And then how do I solve for this thing that I don't know? I can do 2 more steps and I can be done.
You can move the 0.7.
And
No.
see, there's too much shit on the side. What should not be on this
I
side?
think the 1.9.
Yeah, the 1.09. So if I bring it up here, I get, what's 0.71 minus 1.09? Yeah, so I get negative 0.38 equals negative probability of A and B. So this whole thing, this is what gets freaking out people too. This whole thing is a number. That whole thing acts like X did. It's just a little more descriptive than X. It's a number that represents the probability of A and B. But it acts just like X when I'm working with it. It's just an unknown number. So then I can just do what to both sides? Sorry.
Oh.
Divide by negative 1, so now I know the probability of A and B is 0.38. Let that sink in. And if you really wanted to, you could actually replace this one thing with the letter X if it looks more familiar, right? Oh, well, then don't do it if it will confuse you more. That was a suggestion, not a requirement. And then part B and part C are easy. This sounds so familiar. Part B, what's the formula for A given B? What's this guy's formula?
A and B over B.
Yeah, probability of A and B divided by the probability of B. Because the bottom is always going to be the given. And we just figured this out. We figured out A and B just now. So this will be 0.38 divided by the probability of B is 0.64. And whatever the hell that is. And then probability of B given A will be the same thing except over the probability of A. The bottom is always the given thing, which makes sense because when I give you information, you're focusing on that group. So the bottom becomes related to that group. Is that cool? I mean, the numbers are whatever the hell they are.
Yeah, 0.59375.
Beautiful. All right, so coming back to this one. Keep working on this. Hopefully I gave you some help. So now my hint is write the formula for this. You could also write the formula for this one, but you'll notice you don't know enough. I don't give you enough information to use that for part A. If you don't have the formula for this written down somewhere, write it down somewhere. What's that line mean? Do you guys know?
Given.
Yeah.
The given. That line is given. I like it. That line stands for given. How you doing there, little dude? You alright?